Hi everybody, Richard Blyle here. Hey, listen, I want to show you kind of what I've been working on lately. This is going to be kind of a long video. I'm going to apologize for that because it comes with a little story. On top of that, I have I'm trying to freehand this so that I expect I'm going to be moving the camera around a bit. So forgive me if it moves too fast and makes you seasick, motion sick, and if it gets jiggly. This video is going to be a little long because it comes with a story. A friend of mine has a son. Actually, she's my friend's daughter, so I guess it's my friend's grandson. Deathly allergic, like so many more children seem to be in our current society, to peanut products. Not so long ago, somebody gave him a cookie. And even though he asked if there was peanuts in it, he was told that there were not. And he ended up having an allergic reaction that was very, very serious. Landed him overnight in the ER multiple times. And the culprit, the person who gave him the cookie, is probably, well, I'm led to believe is probably not to blame. The person who gave him the cookie is not the kind of person who would say, you know, there's no peanuts in this. Today, so many people have problems with allergies, and it's possible that whoever made these cookies may have done something as innocent as using wheat from a company that processes peanuts in the same plant. If you are not hyper vigilant about it, you just don't know, and there's no blame there. But I had an idea many years ago for a colorimeter, for a mini spectrometer that a person could carry maybe in a purse or in a little pouch. That could test foods for certain allergens. And this inspired me to go ahead and try it. I've been learning electronics, and I have just basically finished a prototype. But before you get excited about this, it's not going to work. And I'm going to tell you why. We're going to talk about that at the end of the video. But first, let me show you what I did. So bear with me as we go through this. This is my prototype here. Eventually, there's a little space here where I'm going to be able to put a sample. If you can see that little button there. I'm using Legos as a temporary housing for it. And this is the prototype. I am using the Arduino, if that's how it's pronounced, Arduino Nano microcontroller here. Because of its small footprint. So I wanted to make this very small, and that is the smallest microprocessor that they have. I learned on Arduino, so I'm sticking with them. I'm assuming I could use others. You'll notice that there's a series of 5 LEDs here. This last one, this clear one, is actually infrared. The idea is, and we have some detectors on the other side. Now what I'm missing right now is something to block the two sides so the light does not get through except through the sample itself. So the idea is this is going to be covered. There's going to be a little slot where a person can put a cuvette with your sample in it and press that button, which is going to activate it. Arduino hooks up via USB cable to my computer, to their own software. It also has this little screen here, if you can see it. Let's see if it focuses on it. Let me zoom out a little bit. So it has a little screen here that gives instructions on what to do. Now I've already compiled the program and it is running it right now, and you'll notice it is waiting for my blank. The software is up and running. If we can focus on that, and I don't know that we can because the backlight is too bright. But you will see that I've already tested it a few times. Now, in order for this to work, the blank should absorb less light, should have more light go through than the sample. So to simulate this, what I'm going to do is turn on this lamp here, and we're going to go ahead and tell it that yes, we are inserting the blank, and the blank would go here. When I do this, you will see the LEDs lighting up one at a time. These are about 5 seconds each because it's running the testing 1,000 times. I'm doing it 1,000 times to get a good average. Right now it is storing the signal it's getting from the light detector here, and of course now it's using this detector, which is an infrared light detector. Now it says insert the sample. Now the sample will absorb some light, so less light will reach the detectors. Again, to simulate that, I'm turning off my lamp. Press it again, and it goes through and it does the same thing. Our message changes every time. Last time it said calibrating, now it says testing. And if I can get this to show you the results here, I don't know if you can read this or not, you're going to see this move. And our new results are coming up here in a second. The idea is this is the percent of light absorbed. Did it work? Should have worked. Okay, this is the percent of light absorbed. Now, for our particular allergen of choice, or for a particular allergen, we would compare these numbers to each other. So we might divide each of them by, let's say, the yellow. And if they come up with a certain ratio compared to one of the other colors, then we would know that there is a risk. And this is something that perhaps should be taken seriously. It would not be able to tell you not to eat it. All it would be able to tell you is if it's a high risk or not. Still better to ask rather than depend on something like this. But like I say, it's not going to work. And there's a couple reasons for that. First of all, the only colors I have available, I've never seen LEDs in different colors than this. They do have white LEDs now, but that doesn't help much. Red, yellow, green, blue, that is not much of a sampling. And the only LED that we have is one frequency of LED in the IR spectrum. The other problem is 4 of these are in the light spectrum. Most of these foods have very little color, which means that the light spectrum, you're not going to see that change much. This is not going to be sensitive enough to be able to do it. What I really need is a source of infrared light with varying wavelengths, because with varying wavelengths we can test specific IR frequencies that correspond to specific functional groups in the allergens. But that is what I've been working on. I'm done with it now. I don't know, I mean, at this point I need to probably need to come up with a way to better deal with the casing so that it blocks out that light except what's going straight through the cuvette. Everything else really should be blocked from one side of the sampler to the other. But it's working, and it's unfortunate. I spent a lot of money and a lot of time on this project, and unfortunately nothing will come of it. Anyway, I hope you all have a great day. That is what I've been doing. And please, if you or a loved one has an allergy out there, please be very, very careful. Thank you.